Hello and welcome to the third part of our RSP basic training on the remote SIM provisioning. And let's go to the agenda. Okay, so now you can see on the screen, so what was the content of the first part of the training. So we talk about why do we have the eSIM. We talked about the applied RSP technology, the eSIM trends and deployments on the market. Talked about the two different concepts defined by the GSMA, so the M2M one and the consumer devices one. Okay, and also about the profiles. What is the idea of the profiles and the idea of the profile switching? Okay, in the second part we talk about the M2M architecture, and it's similar to what we will have right now. So in this 8th, 9th, 10th part of the training, so actually of the agenda, not of the training. Yes, the high-level architecture of the consumer devices is on the agenda today. We'll talk about the roles and players and the consumer device security aspects, such as keys, certificates, and algorithms. Okay, I hope you're ready. So we will start with a short repetition of the main topics of the previous parts, just in order to catch up and that you don't get lost with the content of this part. So we'll repeat it. Let's have a look back on the definition of the USSC, the two GSMA solutions, and the M2M architecture. So to summarize or to test your knowledge, we had some questions. Okay, so the question is, what is the GSMA definition of an EUSSC? What are the two GSMA solutions for the EUSSC deployment? What is the main difference between M2M and consumer devices? What are the common features? Okay, and here we have on the screen so the definition of the EUSSC, which is a USSC which is not easily accessible or replaceable, is not intended to be removed or replaced in the terminal and enables the secure changing of subscriptions. So the EUSSC is basically still a piece of hardware, not a soft SIM. And so the idea is that you have the M2M form factors to solve the vulnerability issue. And so meaning, so the EUSSC is not intended to be replaced or removed from the terminal. And to solve the logical issue of switching between the different operators, we have this concept of the remote SIM provisioning. The two GSMA concepts are the machine-to-machine one and the consumer devices one. The basic, so the main difference between these two concepts is the direction of control. Actually, so the direction for the control comes in the M2M world, so as you remember, from the background infrastructure. So there is no user interaction. It is different in the consumer devices world, because here it is important that the end user has the choice between the operators and can decide it, or at least confirm the decision. Okay, here's the short overview over the M2M architecture. We had those different components. First of all, the EUSSC, the SMDP and SMSR. Yep. We had the CI, so issuing the certificates, the operator, and then the EUSSC manufacturer, EUM, the M2M and M2M SP service provider, and yes, device for some certain function, so for specific functionality of local administration. And plenty of interfaces, as usual. Okay, I hope you remember all of these topics, and now we can dive into the architecture of the consumer devices world. It helps a lot if you get already familiar with the M2M entities, roles and players, and the interfaces, because historically the consumer devices architecture, so the initiative was started a bit later, and so at that time the M2M architecture already existed. So yes, so you can see many similarities that would be easier to understand, but it doesn't need it for this training because I will explain from the very beginning what are the entities and what is its role. Okay, ready? Consumer devices architecture. We'll talk today about the actors and roles, the system architecture and the procedures. Don't be afraid. The architecture looks quite, yes, complex, but it's actually simple if you see so the main component in this architecture is the device, or taking place on the slides. It's the device with a specific component, but if you see it all at once, then it makes it a bit simpler. And please consider, so if to simplify the process, please consider the right part. So don't consider this for the moment. Let's go one by one. So I will just name the new entities and we will go into the details later on. Okay, here we have, let's start with the EUSSC. We have the EUSSC inside of the device. Okay, we have the device with a specific entity which is called LPAD on it. So, or LPA. LPA stands for Local Profile Assistant. So this is a specific entity performing some functionalities. Okay, and then so there are some separated components inside of the LPA. So the LDS, LPD, and LUI. So LUI stands for the Local User Interface. LPD stands for the Local Profile Download, and LDS stands for the Local Discovery Service. This is a corresponding part so to the entities to which it communicates. For example, LUI, so for the communication with the user interface. Yes, and then inside of the EUSSC we have also the according services. Why do we have the D inside? So please, so we'll explain it. I will explain it later. So we can, for the moment, we can keep it as or call it the LPA, Local Profile Assistant. Okay, so then we have the server entities, the SMDP, but now we have the SMDP Plus here. So SMDP stands for the Secure Management Data Preparation. Secure Manager Data Preparation with a plus. So it's the plus stands for the difference between the end-to-end world and the consumer devices world. Okay, now we have the new entity. This is called, so the entity called SMDS. SM stands for the Subscription Manager. On DS stands for the Discovery Service. Again, we have the CI, Certificate Authority. And we have the EUSSC manufacturer. Okay, again, it's similar to the end-to-end world, so we have the operator, for sure. But different to the end-to-end world, we have the end-user entity involved in the system. Though the interfaces, they are not really defined. So all of the dots, or the talks about, shows us the interfaces which are out of scope. Okay, then we have the DLOA register on the right-hand side and the management system, the background system to verify some, yes, or manage to some security topics. Okay, ready to go? Let's dive into the components. This time, let's start with the end user. The end user, so entity, so yes, now you can see the connection, or the interfaces to this, the ESOP for the operator interface between the end user and the operator, and then the ESEU for the end user interface between the LPA and the end user itself. Okay, the interfaces are not really, so actually, according to the definition, they are not defined, but some hints are given, or some restrictions are given. So they are related to the end user. So inside of the specification. Okay, so you'll see it later on. Yes, the end user is not just a person having a commercial relationship with the service provider. So it's different to, so actually the end user exists as well in the end-to-end world in the theory, but here it is a specific role. which is involved in the process of the remote SIM provisioning. So, and the idea is that in the consumer world, so the end user is also asked to interact with his device to confirm the download and installation of a profile, or to initiate a local profile management operation via the end user interface. Okay, now you can see the local in front of the profile management operations. Profile management operations like enabling, disabling. So, but now these operations are local because they are all initiated by the end user on the device. The end user can confirm various actions through a method involving the input of personalized information. So what we already know is the PIN codes or fingerprint. So yes, using this confirmation, or maybe sometimes it's not really personalized information, just a simple confirmation. So with a yes and no, but it depends. The end user can also execute optional functions. For example, set profile nicknames. So we have the profiles which are identified on your consumer device by an icon or by a specific name, but you can also give your own names for this. So this is my best operator or things like this. Okay, the role of the eUSSC manufacturer is actually similar to the role which is defined in the end-to-end world. So yes, to produce the eUSSCs, but here are the connections. So since we don't have, as you probably have seen already, so we don't have SMSR in the system. So means the connection or the main interface, the official interface in the end-to-end world was the ES1 interface to the SMSR. So here it is missing. Yes, and the interfaces is actually the interface to the CI and the interface to the eUSSC. Okay, the eUSSCs are delivered by the eUSSC manufacturers. The eUSSC manufacturer is responsible for initial cryptographic configuration and security architecture of the eUSSC. So it means the eUSSCs has a specific cryptography configuration. We'll talk about this later on, so when we get to the security aspects. And the EUM issues the eUSSC certificate to allow the eUSSC authentication and proof of certification to other entities, and authenticated key set establishment between the SMDP Plus, subscription manager data preparation, and an eUSSC. Okay, this certificate is quite important. So this is kind of the ID card of the eUSSC. The eUSSC manufacturer is responsible for the implementation of any LPA elements or local profile assistant elements that reside in the eUSSC. So just so there is a need for some elements. Yes, so local profile assistant services, or alternatively, we'll talk about this later. So the LPA can be even inside of the eUSSC itself, and then it is the responsibility of eUSSC to implement this. Yes, and now we get to the to this completely new component inside of the consumer device architecture. So the LPA, the local profile assistant. Actually, the role of the LPA, so since we don't have the secure router, so the role of the secure router is split between the SMDP Plus, so this is why we have the plus, and the LPA itself, so inside of the device. So since it is kind of in the middle of the communication, so the LPA has a connection to the interface to the SMDP Plus. So it's already shown as a tunnel, so because it's tunneling to the profile to the eUSSC, so it's the ES9 Plus interface. And then the LPA has an interface ES11 to the SMDS. LPA has an interface to the end user. And inside of the device, there is an interface from the LPA to the eUSSC, which is the ES10 interface, separated inside of the specification, separated into three parts, the ES10A, ES10B, and ES10C. From the outside, it's not visible, but if you're on the EUSC manufacturer side, on the LPA side, so it's quite important. Okay, a local profile assistant. It's a functional element in the device. This is why the D comes from, or in the EUSC, that provides features for the local profile download, local discovery services, and local user interface. And in case if this functional element resides on the device, then it's called the LPAD. And in case if it is inside of the EUSC, it's LPAE. At least from the architecture, so it's possible to implement the LPA inside of the EUSC. And as far as I know, it's currently used by one company. But on the wider range, so on the market, it's the most the component mostly used is the LPAD. So meaning the implementation of the LPA is inside of the device. Okay, where LPA, LPAD, LDS, or LUI is used, they apply it to the element independent of its location in the device or in the EUSC. Sometimes it's not differentiation. Let's go into details of this single components of the LPA. So LPD, local profile download, is not very often used, actually, this separation. So if you remember just the local profile assistant, LPA, so then it's for the beginning it's sufficient. The LPAD is the entity within the LPA supporting functions related to profile download and installation. The LPAD can be used to send profile download requests to the SMDP+. The LPAD receives the bound profile packages, or the BPP, from the SMDP+, via ES9+. Now I'm going too fast. So actually the functionality of the LPA is basically to transmit the profile to the EUSC. So the LPA is receiving the profile data. This data is cut into pieces with the store data commands known from the global platform, for example. And then it transfers the data to the EUSC. So the profile is cut in pieces and then transferred to the EUSC. Okay, and this profile, so it's called the profile package because there is some information additionally inside of it, some cryptographic parts as well. And this profile package is bound. So means there are some encryption modularities inside. Actually, so the profile is encrypted itself, bound to the using cryptographic keys. So, okay, when the LPA is located in the device, so when we talk about the LPAD is named LPDD. So communication with the LPA services to transfer the bound profile packages to the ISTR. So again, we have this issue security domain, root 1, inside of the EUSC. So this is the first communication, so the entry point. So yes, and it's communicating using the ES10B interface. Yes, and here we have it. So now BPP, the bound profile packages, is segmented into store data APDUs. Hope you're familiar with the APDUs. Otherwise, please take a look on the glossary and yes, on the ISO specification. So there is an explanation to the data units used to transfer data. So from towards the smart cards. It's coming in general from the smart card areas. Okay, and then we have the specially formatted data units. So the format is for the store data commands. And the store data commands are used for loading the profile into the EUSC. Okay, when the LPA is located in the EUSC, then the LPAD is named LPDE. Okay. LDS, or Local Discovery Service. Okay, from the logic of the names, the LDS is the entity within the LPA communicating with the SMDSs. The LDS retrieves event records from the EUSC. using the ES11 interface. Okay, so probably it will be better understandable when you know the purpose of the discovery service. So, but just for this moment, so it's always difficult to explain something so in the correct order, because sometimes, so when you start to explain one part, so you need the explanation from the other parts and other way around. So it's difficult to find the right order. But for the moment, just remember, so there are some event records or events planned, and the E in the side of the EOSC is recorded. Okay, from the naming, when the LPA is located in the device, the LDS is named as LDSD, and communication with the LPA services to handle the profile discovery are performed using the ES10A interface. So basically the idea to use this interface or local discovery service to discover the profile. Yes, and when the LPA is located in the EUSSC, the LDS is named LDSE. And then the LPAE may be a feature of the ISTR, Issue Security Domain root. So the root Issue Security Domain. So now the most interesting part from the end user point of view, because it's a local user interface. The LUI allows the end user to execute real-time acquisition and validation of instructions that are needed to trigger actually the profile download locally. Saying locally, especially it's important because in the future versions, so there is also remote management possible. Then so trigger the profile management operation, enabling, disabling, so on. Yes, it means, just to stop on this, the local user interface is actually what you see on your device and what you can use to perform actually the remote SIM provisioning. And if it is located on the device, then it's called LUID, and the communication channel to the LPA services on the EUSSC is using ES10C. Yes, if it's in EUSSC, then it's named LUIE. Yes, it's a different story when it is inside of the EUSSC, but in general, so if it's the LPA is inside of the device, then so the interface, the ES10 interface, is used for the communication to the EUSSC. And as I said, so it's already, so the LPA itself is not encrypting the profile like the SMSR. So the LPA is basically transferring the profile data in the right order to the EUSSC. This is towards the EUSSC, But there is for sure the communication channel between the SMDP plus or SMDS is encrypted. We have the LPA services. The LPA services are inside of the EUSSC. And from the implementation point of view, if you are the EUSSC manufacturer, it's quite important to have this weight or the service implemented inside, so to communicate with the LPA on the device. The LPA services provide the necessary access to the services and data required by the LPA functions. For example, transferring bound profile packages from the LPAD to the ISTP. Okay, here again, inside of the EUSSC, we have this architecture, so with the different security domains. Inside of the EUSSC in the consumer world, so we have a similar structure as in the M2M world. We have the security domain, so EUSSC controlling authority security domain, which is responsible for the cryptographic operations. Then we have the ISTP, so the issue security domain. The security domain concept is coming from the global platform, by the way. And if you are familiar with this, you're already on a good way to understand the specification. Yes, and the security domain P, so ISDP, is a kind of a profile container, which will be filled with actually the profile. And the ISTR is the first entity, first security domain to store, to welcome the profile data information. Okay, so the services transfer the data from the LPA to the ISDP. then the services provide list of installed profiles. Since we have this user interface, you can see the list of the installed profiles on the user interface. There is the EUSSC ID inside of the EUSSC, and it can be retrieved using the retrieve EID service. Yes, and local profile management operations, so yes, coming from the LPA, so they are performed using this LPA services. The LPA services are mandatory even if the LPAE is provided in the EUSSC. Okay, this is to the LPA services. Now let's take a short breath before we go to the other details, to the other parts of the other components. Hope you remember everything what I just said. You can just recover this and bring it in front of your mind. Set. Okay. The SMDP Plus in the consumer device architecture. So we have this role of the subscription manager for data preparation. And again, we have the similar to the M2M world. So we have the ES2 Plus interface. So Plus stands for this enhanced functionality compared to the M2M. We have the ES12 interface, which is a new interface to the SMDS. And then we have the ES9 Plus and ES8 Plus interfaces to transfer the profile and yes, for the communication with the LPA, so between the LPA and SMDP Plus. And for sure we have the channel planned so to the CI, because again we have certificates inside. So but this interface is out of scope. Okay, the SMDP Plus provides enhanced functionality compared to the SMDP from the M2M world. And the role of the SMDP Plus, similar to the SMDP, is yes, data preparation, so kind of data preparation of the profile. It's actually the first instance where the profile gets into, and the first also the responsibility so is by the SMDP Plus. SMDP Plus prepares profile packages, secures them with a profile protection key, stores profile protection keys in a secure manner, and the protected profile packages in a profile package repository. It allocates the protected profile packages to specified EIDs. So it means that all of the profile packages, not just flying around, so that so there is a way to allocate this to the specified EIDs. So this is part of the process when it is yes, of the remote SIM provisioning process in general. The SMDP Plus can issue or remove event registrations on the SMDS. So actually on the SMDS, so there are some events being registered, and yes, this is the responsibility of the SMDP Plus issue to remove event registrations. SMDP Plus can securely deliver bound profile packages to the LPD using the ES9 Plus interface. SMDP Plus can be used to administrate the ISDP and the associated profile during download and installation using the ES8 interface. And the SMDP Plus is used by the operator to order profiles for specific EUSSCs as well as other for administrative functions. Okay, yes, it means there is a connection between the operator and the SMDP Plus. And for the ordering profiles, there is a specific communication. So SMDP Plus is used for this by the operator. SMDS. Completely new role, discovery service. This is a role as kind of a DNS server, in simple words. So yes, actually, the purpose of this component is to get the address of the SMDP Plus, so that in order to download the profile, so when the end user initiates the communication, yes, then the SMDS, so it can ask the SMDS, if it doesn't know the SMDP Plus address, it can ask the SMDS to get the proper SMDP Plus address to download the profile. This is the idea behind. Okay, and here you can see for sure the interface for the security to the CI, which is not defined, but it's meant that there are some security configurations on the SMDS. Then we have the ES12 interface to communicate with SMDP+. We have the ES11 interface to communicate with the LPA, or the LDS actually. And the ES15 interface to communicate between the different SMDSs. So we can have 2 types of SMDS, or multiple SMDSs. The SMDS may provide addresses of 1 or more SMDP pluses to the LDS. A particular SMDS can be specified by the SMDP plus to issue or remove event registrations. So actually the SMDS contains kind of communicates using this specific events. Events meaning in terms of event of the profile download. And this kind of events, this event is registered. Yes, and as I mentioned, so there can be 2 types of the SMDS, the root SMDS, and alternative SMDS. And therefore the communication can be cascaded via root SMDS and alternative SMDS. So first also you don't ask the SMDS, so you don't get the SMDS SMDP plus address from the SMDS directly. So you may go, so if there are several SMDSs involved, you may go several steps by using this. So first of all, asking the root SMDS for the right address, then your request will be delivered to the alternative SMDS, and then it goes to the several alternative SMDSs, and then it's finally by the SMDP plus and gets the address. Yes, and the deployment can be controlled using SMDS functions on the ES15 interface. Okay, this is a part to the SMDS discovery service. Now we have 2 components like the DLOA register communicating with the management system. That's just a registration component. It's a digital DLOA. It's the digital letter of approval. So you probably know the letter of approval. And so here is the digital format of it defined by the global platform. Yes, and it's signed by the DLOA authority. Yes, in the context of the RSP, a well-known DLOA register shall be defined containing all the valid letters of approval in a digital format delivered by the according authority. So we have a kind of registration. Okay, this product is approved, this product is approved, and here's the letter, here's the digital format of it, please retrieve it. So this is the basic idea. It's proposed as an additional level to compliance verification recognition. So a digital certificate provides confirmation of an SGP24 compliant product. SGP24 is the specification defining how to get certified and become a compliant product. So we have a list of products, basically, compliant products. And the DLOA provides the platform identification of the compliant product. So there's this item. And within the device info and or the EOSS info too. So actually now it's very detailed for the basic trainings. So these 2 information parts that are received during profile download. The SMDP Plus can perform an eligibility check, which may include the verification of the platform identifier. Okay, this is the idea. And then the management system. The management system is actually a system, any authorized system, for example, the MNO backend system on SMDP Plus, interested in verifying of the level of certification, evaluation, and approval, qualification or validation of an EOSC. Basically, the entity having access to the DLOA registrar. Here, once again, so the picture of the LPAD. So with the LPAD, so the consumer device architecture, and the interface is going to the LPAD. So the existing interface is the ES6 interface. So this is not changed compared to the M2M world. So this is the interface from the operator to the ES6. Sorry. From the operator to the EUSSC, the interface is called the ES6 interface. Yes, on my slide I'm using this architecture of the LPAD because this is the most visible, because it have the simplest way to see all of the interfaces. The new interfaces are those interfaces to the SMDS, and yes, actually between the LPA and the EUSSC. And then we have also the improved interfaces. So on the ES2+, ES9+, and ES8+. Interfaces which are not covered by the GSMA specifications. SGP22 is the consumer specification. Okay, let's have a short break.